So this video is going to be a very basic introduction to vectors, and we're not going to include any new concepts except for the two words vector and scalar. Okay, so we're going to talk about the hard concepts involving math and a bit of calculus in later lessons. So right now we want to know what a vector and scalar is. So let's talk about scalar first, it's easier. So scalar is much like the opposite of vector, and it's basically any type of value that doesn't have a direction, so it only has a magnitude. So what exactly is a magnitude? You can think of this as the size of, this value here. And for example, I'm going to give a few examples of scalar quantities, such as let's see, mass, your grade, the grade you get in class, your age. So hopefully you see that these don't have direction. You can't say that this person over here is 50 kg to the right. That's just fundamentally flawed. You can't just say I got 19 points out of 100 to the left. That's also flawed. You can't say, okay, right now this person here is, I don't know, let's say this person here is 16 and they're 16 years old upwards. That's just not right. Like, scalar quantities just don't have any direction. Now, vector quantities are the opposite of scalar. So they have a magnitude in size. They have a magnitude and they also have a direction. So types of vector quantities involve, let's say, we can say displacement. So you can say I walked 5 meters to the west. That makes sense, right? I walked 5 meters to the west. And you can also say, so let's say we can have force. You can say I threw this object 10 meters to the right. That makes sense too. So you can also say, I don't know, maybe you can say like the direction where something is going. Like, you can just literally say I walked 10 meters to the north of our house to the shop. That's also a vector. So anything that has both magnitude and direction. So now we know scalar and vector. These are two important concepts, so let me just underline these again. So now we know scalars and vectors. We're going to take a look at how exactly vectors actually work. So basically we're going to identify some scalars and vectors from each other, so we actually know when we see a vector and when we see a scalar. So let's say I said today I walked for 10 kilometers. So I have this number here, which is 10 kilometers. Okay, so is this a scalar or vector? So a scalar only has magnitude or size. So basically a scalar is any value that only has a number there. A vector is any value that has a number and also a direction after it. So this was obviously a scalar because we see no direction. There's no 10 kilometers to the right or no 10 kilometers to the left. It's only 10 kilometers. So if I were to say, I started at my house and I ran 10 kilometers, guess where I ended up? You wouldn't exactly know. You'd have a wide range to guess from. Or if I told you a vector quantity, let's say 10 kilometers to the north, then you know exactly where I ended up at. So 10 kilometers to the north is vector because it has a magnitude, which is 10 km, and also a direction, which is to the north. Okay, so that's the difference between scalar and vector. And we also have, so let's say we have, let's see. So we can say we can say this person here walked at a speed of, so let's say I walked at a speed of 3 meters per second. So is this a scalar or vector? This is actually a scalar because despite the meters per second, which may make it look complicated, so it's like a vector, yeah, it doesn't have any direction. Meters per second is literally just a unit. If we just ignore the meters per second, we only have a number 3. So we aren't exactly sure which direction did we walk. Did we walk in a loop? Did we walk to the north? Did we not walk to the east? Did we just, stay on the spot? What did we do? Which direction did we go in? We don't know the direction, so it's a scalar. Now, if I said we walked 3 meters per second, let's see, to the right. So let's just say I walked 3 meters per second to the right. Right now, we know our direction, which is to the right. It may not be really specific if I'm just telling you this because you don't know where I am, where I started from, and where I am facing. Yet it already has a direction. So this is what makes it a vector. So let's try another example. Let's say I can say let's see. So if I have so Tom, let's just say this random person, Tom here, pulls, or they pull a balloon down from the air. I can say he pulled the balloon down with a force of 5 newtons, right? I can say that. So that's just a guess. I'm not exactly sure, but okay, let's just say it's 5 newtons of force. So this is a scalar quantity because we know that Tom used 5 newtons of force to pull this balloon down, yet we're not exactly sure where the force went. I mean, what if he's doing a handstand and he decided to pull the balloon down in the other direction? So we don't exactly know which direction this 5 newtons of force is applied to, so this is a vector. Sorry, this is a scalar. It only has magnitude. So we add direction now, 5 newtons to the ground, or downwards. We have a direction. Yes, I understand that we're not exactly sure what downwards mean. I mean, if he's doing a handstand, then his downwards would be our upwards. Yeah, we already have a direction, so if we were to have more detail, we would know exactly how the 5 newtons of force is applied. So this is a vector. So there are 3 examples, and I explained scalar and vector in this video. Next lesson, we're going to be featuring how to represent vectors in terms of the mathematical way. So there's also the physics and computer science way. But okay, we're going to do the math first. So thanks for watching.